discussing in the earlier class. Yeah, we discussed about the exceptions, and I do see 4 or 5 members sent an assignment, and one guy did really nice. I didn't remember the name, but the way he tried with the exceptions, keeping the multiple exceptions together in a single catch. Uh, so yeah, but what I'm going to ask you guys is like just try to finish, and as and when the topic goes on. If you observe, right, like we are picking one topic at a time, and we're focusing on the topic and moving into another topic. So if you miss the topic, or if you forget to practice the topic, you're never gonna get a chance to do the practice again, right? So just focus in those lines, and keep that in mind. And next is threads and synchronization. Threads and synchronization, basically what happens, mm, in a day-to-day, see now, right, I have my laptop, what do you call, running, and I can open Eclipse, I can open Word, I can open browser, I can open my running session, I can open Paint. So there are a bunch of things I am doing it in parallel, right? Right, if I want to go ahead and write the code and come back and write it here, some changes, right? So what I'm doing is, by using the CPU process, right, I'm able to do multiple programs, multiple processes, like multiple tasks at a time, right? I mean, you see, now I can change it here, I can go back here and then modify here a new file. What I'm doing there is like, so if you want to play a movie, songs, well, you can do it, right? Modify, PDF, Eclipse. So multiple processes you are able to execute, and you can switch between the contexts as and when you want, right? You can switch between the context. This is, let's say, this is one context, this is another context. So you can switch between the context as and when you want, right? So in the same lines, so this is nothing but a multitasking. What kind of multitasking is this? It is kind of a process based multitasking. But same thing in Java. Java also, like, we always run a program. When you run this program, what happens? It loads the class, it creates the class, and it starts with the main. What is this main, right? It's a main thread. Like, one thread will be created. This is the application thread. Um, it will start using that thread. It started processing here. Okay, he started creating file, and okay, you want to monitor this. Okay, and something goes wrong, you want to print it. Okay, next again you want to monitor a few more statements. Okay, you want to add the card invalid exceptions. Okay, what is card invalid exceptions? It will go there and it will look at around. It understands that, it loads the object if required, and keep it in mind, and then it will go validate method. Okay, who is calling validate method? Who is calling validate method? He need to jump here. So someone is tracking all these things, right? Who is that guy? That guy is the main thread. That guy is the main program. Main program is the one who is tracking it. Java also. But there are some situations where you want to run multiple tasks. Like, let's say, um, real-time example. let's say yeah, let's say your simple task, right? Like you have you plan to move your stuff from one location to another location at your home, like you are so what you will do, you will call you will get the U-Haul, and you know a couple of your friends and you call them. What you will do is, like like let's say your stuff is like at least 5 to 6 times you need to carry in U-Haul, and you have 5 friends. So what you will do, first time you load all of your friends together, loads the stuff into the truck. Once it get filled, if you think smartly, what you will do, you don't ask all of your friends and you go together in that U-Haul and go and drop it there, right? What you will do, you will ask couple of one or two friends, guys, you guys just drove the U-Haul to the new location and drop the stuff and come back. And remaining people, you want to utilize them in a best way so that the things will get done quickly. So what you will do, you will come back and keep the stuff ready in the boxes so that you can move them as and when they came, rather than once they came back and start packing it up. You will try to pack as many as you want, as many as you can, before the trucks come, before the U-Haul comes back, so that you can utilize the time efficiently, right? So in the same line, using the time efficiently, using the processes, the system efficiently. In your case, your system is 5 people and U-Haul. Using the U-Haul efficiently and using the 5 people efficiently, because you don't want to pay more than one day. So if you want to finish within the time, otherwise you need to end up paying more money, right? If the stuff is left even by evening, you need to pay more money, right? So it's kind of like efficiency in terms of money and in terms of processes that you have. Same thing in terms of in the concept of Java also. When you are running your program, you want to utilize the best, you want to do the best memory uses, and you want to do the multiple tasks and finish the program as fast as you can, as fast as you can. Okay, so that is where thread based multitasking comes into picture. Thread based multitasking comes into picture. So like we discussed, this is the JVM, and our first main program is main method is tracking all the thing, right? Tracking all the stuff from here to here, right? So in this process, if you do like this sequential, it may take 20 minutes. There are certain logics, one or two logics here, which are independent of each other. 1, 2, 3, let's say 3 different business logics you included in this process, and these among these 3, they are independent. They are not depending on 2 is not depending on 1, 2, 3 is not depending on 2 or 1. So they can run independently, but at the end of the day, you need to return the all the conclusions result, all the conclusions result. Okay, so another best way I can tell you is mm, you have data in Excel file. Okay, now I have data in XLS file and I have data in database. Okay, some data related to the information, and you wrote some logic here, to get the data from XLS, and to get the data from database, and then merge the data, give it back to the system, whoever caller. That is your task. So you wrote some logic here. So if you wrote sequential logic, I mean, first read the XLS data, then read the database data, and then merge them. So for reading XLS data, you are taking 10 minutes. Okay. For reading database data, you are taking 8 minutes. Okay. So if you do merge will take another 2 minutes, let's say. Okay. Merge logic will take another 2 minutes. So if somebody runs this program, if we run this program in sequential, they are going to get in the data in 20 minutes, right? 10 plus 8 plus 2 minutes, 20 minutes. In order to make the system efficient, what you can do, as the data in XLS, as the data reading in database is independent, you can run parallel threads, thread 1, thread 2, and fetch the data. So this time what happens? In the first 10 minutes, in the first 10 minutes, you will get the both information with you. Right, this will be finished in 8 minutes, thread 2, but as thread 1 is, you still, before merging, you want thread 1 as well, you need to wait another 2 minutes. So you will get, by 10 minutes you will get the information from XLS, from database. Now you're going to merge the data in 2 minutes. So how much time it will take? Now you reduced it to 12 minutes. But still the main thread is running here. Okay, supplementaries, these are the sub threads will be created, like as and when you want. From main thread you can create a sub threads. That is what called multitasking, thread based multitasking. Okay, you see the value of doing that. Okay, having said that, what is available in Java, what are the best ways to do it in Java, right? This is the next question comes into our mind. So in those lines, you can create threads, in two ways. Okay, that is child threads in two ways. One is by extending the thread class. Okay, there is a built-in class called thread, or by implementing the runnable interface. Another runnable is built-in built-in interface, runnable interface. By implementing runnable interface or by extending the thread class. Okay. Let's see. Oh, let's write quickly one program, basic program, and then we'll go a little deeper into the concept. Which class we can write? Simple class we can try, right? If I start this one, you guys get confused. Okay, so What are the different ways that we can create a thread? One way is class my thread by extending the thread class or by implementing the runnable interface. Okay, let's try with extending thread class. So from where you get this thread class, it is available in java.io. Java.lang.thread. In this class there is a class called thread. Okay, now you can create threads for this class. Can you create threads for this class? No, because in order to create the child threads, you want to, like, let's say there is a logic here which need threads, which needs a thread concept, which needs multitasking. Then you first, what you need to do is you must extend the class with extends thread, or another option is implements runnable. Okay, either one of them you can do. Then let's say what we'll do is a simple program we'll try and then convert into. I'll just take one static value. When I take static value, what does it mean? You'll have, irrespective of whatever you do, you'll have one copy of memory. Remember that. Okay, and public, I'm writing my own constructor, my thread, and in my constructor, my own constructor, what I'm doing is I'm going to write string. I'm taking some value, name, okay, and if you look at this guy, right, what are the available, what are the methods that are available? Control O. So these are all the different methods, that has been available in thread class. These are the different methods that has been available in thread class. And second thing, thread also implements runnable. So if you go here, interface, run method also there. Okay, agreed. So if we go here, he implemented, because he extending the runnable interface which is having a run method, he must implement the abstract method. He must implement the abstract method, right? So he implemented. So these are all the different methods that you can make use of in the process of making your program multitasking through threads, right? So one of such method is run. Okay, so I'm going to utilize that method. I'm going to override that method, public void run, and then for int x assigned to some number, I'll just write some logic like for loop. I'll just repeat by passing the threads. Okay, as less than 10 plus 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 plus. I'll just increment every time the x value, and then SYSYOT. I'll try to display there is another method called get name plus, you'll understand, hang on. Threads are a little bit tricky, but it's not complex. I am going to write call directly thread dot sleep. I'll say 1000 seconds. It represents in seconds, which means milliseconds, which means 10 seconds, not 1 second, sorry. So as you are using, it is showing some exception. Catch interrupted exception p associated. Looks like I can directly print this, right? Come on. That's it. Oh, this is the simple my thread class. Okay, so I did some new things which I haven't explained to you. So if I go here, you are going into the thread class. See what I'm trying to do, right? I'm utilizing the functionalities that has been there in the thread class. I haven't explained you, but just for showing one example, and then we'll go to the theory and then come back. Okay, here I'll say set name of whatever the name, t name, and then start. I'm just utilizing all the functions that are, basic functions that has been there in the thread class. Okay, now this is my thread, and which is having static method, and I have a method my thread constructor, which will take a name, and by using the thread class set name, because I can access the parent class thread methods, right? Set name, I pass this set name, so it will be passed to, it will do some blah blah stuff, and finally the local name will be available. So this is the local, this dot name, in a sense, thread class name, that is the name you are assigning it to. Okay, and then you run the one of the methods start. What it does we don't know for now, and then you wrote one of the, you try to override one of the method, run method. Okay, so and in the run method what you did, you just looped it, you just incrementing the basic static value, and each time the for loop runs, you try to run the whatever the name that has been set here, you're trying to access the get name from the thread class method, and you are displaying the incremented value, and then you are saying go to sleep for some time, for 1 second, and then repeat this. What happens we'll see. Before running this method, you need to trigger this guy, right? How do you trigger? My thread t1 equal to new my thread, I'll say Java. This is my, I'm just naming it as Java thread, and then t2 new Scala. Yeah, that's it. I don't want to do anything here. Let's see what happens. Are you guys seeing the output? So if you look at here, you took the value 99 and then basically what it's supposed to happen, right? Simple. When you run this method, it should go here. It initialize this object with t name Java, and basically the start will do what it's supposed to do. It should start run the method. It should start basically start will trigger the run method. Okay, I'll explain the details, but just for the sake of now, start will run this run method, and then it should run for Java and then come back, need to start for Scala, right? That is what we expected. But what exactly happened, if you observe, it first Java displayed and then Scala displayed. Let's try one more thing. Now see the values, the way they are displaying 101, 101 same values. So earlier if you look at, let me say, if um, get name dot equals of, I'll say Scala. Scala sleep, or just for the understanding, Java sleep for 2 seconds. Let's run this program. See, first Java run and then Java didn't run until it finishing the Scala. Then now see, Java started running. Because you explicitly said when the first time it came, it displays the Java, and then next time, and in the process of continuing, it just looks at, you are explicitly saying go and sleep for the thread Java for 2 seconds. By the time what happened, Scala finished this loop. So they are sharing this loop, this logic, they are sharing this logic, how they are sharing, what is the thread life cycle, how the the communication between happens between the two threads, and how do the other thread knows whether the current thread is running or not, how do the main thread will know both are finished or not. So these are the concepts behind running this program. Let's go back to the concept and come back to this program again. Okay, this is the thread life cycle. Let me see if I have. So basically what happens, it's very clear here, right? This is the life cycle of a thread. This is the life cycle of a thread. What exactly the life cycle of thread is? What happens to this life? What happens to that thread? Like if you want to start the thread, what you need to do? If you want to destroy that thread, what it need to do? So from the beginning to the end, how it behaves by using what you can do, by what are the methods that are available for in order to process the thread efficiently comes into this life cycle of a thread. Okay, so what exactly happens, right? So when you create a thread, right, after creating the thread, where did you create in a thread in your program? Where did we create a thread in your program? This is the thread creation, right? Creation is nothing but creating an object, right? So after creating the thread, we have to call the start method. So this is the new state. Okay, so the thread will be initially in the new state. When you create a thread, here, it is in a new state. Okay, the state name is called new. And then when you state thread dot start, when you say thread dot start, that is nothing but start, then it will move to ready to run state. It doesn't start running, it move to ready to run state. Here all the threads are going to sit. If you created 10 threads, 10 threads will go here, thread dot start. If you run start on all the 10 threads, then this ready to run, all the threads will move into this ready to run state, not running state. Okay, remember, all the threads will go into ready to run state, and from here it will move to running state. How does they move? Based on the scheduling algorithm that has been defined. Okay, and based on the priority that has been defined on the thread. Okay, if you set one thread for higher priority, if you set another thread for lower priority, what is this priority, right? You may have a doubt. So T1 dot set priority. If you set the priority like high, low, max, minimum kind of things, based on that the priority of the thread will say, like, certain logic you must execute for sure before doing anything. So you can set high priority for that thread, right? Something like that. So that the priority and scheduling logic will determine to move a thread from ready to run state to running state. Okay. And then here the threads will start running. So from here it can go in different ways. If you make the thread to sleep, it will go into the sleeping state, which means it will literally doesn't do anything whatever that sleeping time that you give. So here what we tried here, thread dot sleep for 2 seconds. Which thread we said? Java thread. How does this thread is understood by just Java? Because this logic is been executed by Java at that particular moment, and this thread will be assigned to that Java, because what you trying to do here? Thread is what? Super class of your my class, my thread class, right? Agreed. So it can move to sleeping state, or else running state too. You can, if let's say it is let's say if you have a logic here in this highlighted block, you have a logic to go to the Excel sheet and fetch the data. Okay, if the Excel sheet data has been outside the JVM, right? So it is a network call, and it is reading, it is go to the IO state, because what happens is, let's say you try to access the Excel sheet, and you are you modifying the Excel sheet, and you are running this program, and you are never allowing Java program to read the data completely from your Excel sheet, because you were modifying, so the Excel sheet has been locked by you. So this Java thread not getting an access. So in those status, it goes to blocked on IO or locked monitor synchronized block. Synchronized block, don't worry about it, I'll explain later. So basically it can go into the blocked state. Okay, or else it just like sleep, you can say wait state as well, thread dot wait. Okay, so if you say wait, it will go into waiting state. What is the difference between going into the waiting state and what is the difference between sleeping state? When the thread goes to the sleeping state, before going to the sleeping state, you already let the thread know how much time it need to go into the sleeping state, like 5 seconds, 10 seconds, or after finishing this kind of things. But in waiting state, when you are moving a thread from running state to the waiting state, you are not letting that how much time it should wait. You just push that to go and wait. Okay, then what happens for that thread? How come this thread will become back to the running state? Basically that waiting states, whoever pushed that thread to waiting state. Okay, let's simple logic, right? Like, again, just apply to your practical thinking, right? So your friend is waiting at bus stop, and you called him, and in the process you get to know you are going in the same direction, and you asked your friend, hey, just wait, I'll come and pick you, right? So that time, even though some buses came in the direction that you want to go, you still be in the waiting state until you come and pick him up, or else you can call him back, my plans changed, you can go in your way, right? So whoever asked you to go into the waiting state, that guy has to notify back saying that, hey, you can come back to the ready to run state. Okay, so if you observe, from running state, it can go to the blocking state, it can go to the waiting state, it can go to the sleeping state, or it can go to the dead state, right? In any of these cases, apart from dead state, blocking state, sleeping state, waiting state, once it got, like, let's say somebody notified in the waiting state, go back, or else somebody after 5 seconds it realizes I'm done sleeping, they don't directly go to the running state, they again go to the ready to run state. Then again they need to be in prioritized, whatever the priority is. If it is nobody is in ready to run state and running state is clear, nobody is using it, then ready to run state will use scheduling algorithm and priorities again and push that to ready running state. Again same thing will happen until it becomes dead state. Okay, this is the life cycle from the creation. So what will happen? After creating the thread, we have to call the start method. It is mandatory. Okay. After calling the start method, thread will be in the ready to run state. Based on the scheduling algorithm and priorities, thread will get the CPU time. After that, run method will be called by the JVM. Okay. Thread start here. This is the run. Okay. Now, thread will be in the running state. So here calling thread dot start or start method indirectly calling the run method, because you just can tell them start the vehicle. When it starts, it depends on the ready to run state to running state and scheduling algorithms. When it runs, it depends on the scheduling algorithms, ready to run state to running state. Okay. Then what happens, we can call sleep method on the running thread, then thread will be moved from running state to sleeping state. Whatever the time elapsed, right? Whatever the time that you mentioned is elapsed, the thread will be moved from sleeping state to ready to run state. When you call wait method on the running thread will be moved from running state to wait state. We have to call notify all methods to send the waiting thread to the come back to the ready to run state. Okay. Again, it comes to use the whatever the scheduling algorithms. What are the scheduling algorithms we have? Like, least recently used or round robin. These are all the different scheduling algorithms are there. Round robin is based on slices. Like, each thread, irrespective of their priorities, will get 5 seconds. Do whatever you do in that 5 seconds. Come back and continue after remaining threads will finish. Least recently used is like, if 10 threads are used here, then which one is the least used, or else another concept called I don't remember exactly. Another scheduling algorithm is there. I'll let you know. And next thing is, when running thread is waiting for a resource which is busy, then the thread enters into the blocked state, right? When the running state, when the thread is running, when a running thread is waiting for a resource somewhere like XLS or PDF or database which is busy, then the thread will be entered into the block state. Later the blocks, once that you stopped modifying that Excel sheet and your Java thread got an access, then it will back to the ready to run state. Okay, so let's do some more experiments here. Instead of that, what I will do is thread dot yeah, they deprecated this method. So earlier we have this method. When you run this method, this will be stopped, thread will be stopped. Now they deprecated, which means deprecated in the sense they stopped. It doesn't work. That method will be removed, kind of thing. Okay. Now you understand this program a little bit better after that life cycle. So what exactly? You just extended the thread class, and then you wrote, like, you set the name because you want to play around the name of the thread based on the name of the thread. So you set the name of the thread and you start. When you start, what happens? Based on the schedule, it will go to the ready to run state. Based on the scheduling algorithms, whenever it is free, it runs the run thread. And then it runs whatever the logic that you written inside. Once it is done, the thread will be in dead state. Let's say if I run T1, T2, T3, T4 .NET, right? If I run, the last one will be Java. Because you let remaining ones to run everything, but you are just asking to Java to stop it. Java to sleep, go to sleep and then come back after 2 seconds. Let's say I just mentioned it here like 5 seconds, okay? So your program will wait until sometime 5 seconds, then only Java will start. See? Every time again 5 seconds. Got it? And same thing you can do with the runnable as well. Give it a try with runnable. Okay, that's it for today. I will let you know by 5 if we have a class today. Somebody mentioned Somanchi. Hey Siva, you asked something, I missed it. Which part you want explanation again, Siva?